of BIOCORIN in the framework of the project. Great importance has been devoted to the environmental test of the coating, and the main aims of the environmental tests performed were the evaluation and quantification of the environmental performance by means of eco-innovation indicators, measured also by specific lab tests. Life cycle analysis and life cycle cost assessment of the solutions and the defining the advantages and disadvantages of the solution. About the quantification of the environmental performances, laboratory tests have been set up and mainly in the seawater, because the seawater is the worst medium for the corrosion. In order to perform the laboratory test, we have used a microcosm incubator system in order to reproduce natural dynamics by simulating different environmental conditions, controlling temperature, pressure, gas exchange, light and current speed. Each microcosm is equipped with autonomous thermostatic circulation, dark light regulation, and with electrode to measure in continuous physico-chemical parameters. The carrying out of independent microcosms allow contemporaneous simulation of the same study area during the same experiment to check different conditions, reproducibility and reliability of the results. The incubation have been performed with the marine samples in the sampled in the demo sites, and the main parameters tested were dissolved oxygen and temperature. Obviously, in the alternating of oxic and anoxic condition, catalyze a lot of reaction and could be a way to I don't know, to cause strong environmental effects and impacts. For these reasons, a specific tests have been set up alternating the environmental conditions for 2 months in the RISE incubator system. The solution tested in laboratory are reported in these schemes: the stainless steel control, 2 commercial paints, and different BIOCORIN formulations. So in this page I put an attention on BIOCS2 and Biofilm that you have known before in the previous presentations. The formulation tested are schematized in these slides. These are the products, the number of tests, different tests, the time, total time for the test, and critical parameter tested. These are an example of physical chemical parameter for test toxic. These are the chemical parameters, and this is our condition. And this on the right you can see the physico-chemical parameters of the test oxic and anoxic alternating, because we have step 1 in aerobic condition, and then the sample, the environment of the sample pass through an aerobic condition in phase 2 and again in aerobic condition. The environmental impact results on BIOCORIN formulation take a great effort, as previously said, and this is our pathway. We have started to test the previous formulation and we had a result. We had determined the biotoxicity. After that, the formulation was upgraded, and we have tested again the new formulation, and we have found a delamination effect of this formulation. So after that, the formulation was upgraded again, and the last tests were optimal, without criticism, and so now we present the results. This is the first results on biofilm formulation in oxic and oxic test, as previously said. These are the sample at the start of the test, and these are the samples after 2 months. This is the control, and these are our samples coated with biofilm solution. These are our samples in the oxic test. These are in this row you can see the coupon at the start of the test, after 1 month, after 2 months, and after 3 months, with different seawater. The coating, the biofilm work well and contrast the rust. We have some defect on the edge of the samples, but are due to defect in the painting coupon. And you can see also this coupon with this biofilm, yellow-brown biofilm. We have analyzed this biofilm, and it was of inorganic nature and without iron, so no rusty, but there are a lot of ions that are present in the seawater normally. So sulfur, sodium, magnesium, and calcium. And we, with microscope, electronic microscope, we have detected also different amorphous crystals. These are BS2 formulation with microorganisms, and you can see the coupon at the start of the test, after 1 month and after 2 months. Our sample in comparison with the control samples, and also in this case our formulation worked very well. After that I will present you the environmental impact test on the environmental impact of the commercial paints of 2 systems based on copper oxide and zinc oxide. You can see at 1 month later, the samples after 1 month of test. This is the control, and after 2 months. This is the beginning of the test. We have, in this case, we have detected great release of copper and zinc, copper for the system 1 and zinc for the system 2, especially that increased abruptly in the anaerobic phase. The average release of the system 1 and of the system 2 were 71 milligrams of copper per square meter per day and 100 milligrams of zinc per square meter per day. In the system 1, we have determined also another a release of VOC, volatile organic compounds, that account for a flux of 200 micrograms per square meter per day. This release obviously has an impact also on the toxicity, and we have detected a strong biotoxicity for the two commercial paints. Here in the graph you can see the percentage of viable fish EC50 on viable fishery, and the numbers that you can read in the graph are the minimum concentration in order to obtain the EC50. This biotoxicity was also tested and measured with Dunaliella tertioflea and Artemia salina. The environmental impacts results are schematized in these slides, and you can imagine what happened in Harbour or port with a lot of infrastructure or boat or something else with this paint. The pollution on the effect it was the pollution of the environment. This is our final scheme for the two last formulations, BIOCS2 and Biofilm formulation, in comparison with the commercial product. Now we will present the life cycle analysis and life cycle cost assessment of the solution, and Valentina will show you the result.